Good day to all. Now we are going to discuss the conduction system in our heart. So the conduction system of our heart, the meaning of this one is the heart. No? The heart has its own electrical impulse inside the heart. That's why it's called intrinsic. If you say conduction system, there is an electrical impulses that is being transmitted inside the heart among the muscles of the heart. Okay, so without, it says here, intrinsic conduction system. You say intrinsic. It is inside, no? So inside the heart muscle, there is conduction system, and it is also called nodal system. If you do you know what is nodal system? What is nodes? No? Nodes inside the heart muscle have nodes. Okay, so in these nodes, there are electrical impulses that are being emitted. You try to hold your neck. Okay, so in your neck there are nodes, and inside the heart there are also nodes, and there are a system of nodes inside. Okay, wherein these nodes are emitting impulses to contract the muscles. No? So the contraction of muscles depends on this intrinsic conduction system. So it says here that heart muscle cells contract without nerve impulses. So this is very important. No? These two words are very important. Without nerve impulses, meaning without the influence of our brain, the heart will pump, okay, in a regular, continuous way. If you say regular, continuous way, 60 to 100, okay? So the cardiac muscle can beat independently. So they say intrinsic, they beat independently. So the muscle cells in different areas of the heart have different rhythm. So take note of this, no? It says here that in different areas of the heart, they have different rhythm. Okay, so first area is the atrial cells. It beats around 60 times per minute. So remember this one. So in the atrial cells, the heart beats 60 times per minute. So what do we mean by this one? And unifying control without unifying control. Okay, so the eight, all the heart cells from atria and ventricle cells are all interconnected. They are being unified. If you remember, no, we have this what we call the tight junction. So the muscle cells or cardiac cells have desmosomes. Did you remember desmosomes? We have desmosomes. Okay, so desmosomes. We have desmosomes that connect all the cardiac cells intact together so that they will not be pulled apart. So this is one important characteristic of the cardiac cell. So we have this one, no? The cardiac cell. And always remember, take note, cardiac cells or cardiac muscle are only found in the heart. You cannot find it in any part of the body. Okay, so they are the only one with intrinsic conduction system. And also, they have what we call the gap junction. This one. Okay, so we have the gap junction. This gap junction is very important in order that the cell can communicate to each other, and there will be exchange of ion from cell to cell to create contraction. So nerve impulses from one cell to another is being transmitted because of this gap junction. So in the cardiac cell or cardiac muscle, this structures are very important in order to have a very, very unified or unifying control system for the conduction of the impulses inside the heart, and there will be coordinated muscle contraction from atria to ventricle. This is an example of cardiac muscle cell taken from a microscope in a slide. No? So if you look at the muscle cell, their structure is like this. Okay, so what is to remember with this one? So if you look at the muscle cell, they are branching. No? It branches. So one structure of cardiac muscle cell is they are branching cell. They are called branching cell. And they are the only one that is branching cell. So cardiac muscle cell only found in the heart, and it is a branching cell. Okay? It is also striated, and it contains this intercalated disc. So if you look at this, no, there are branches. So it branches like that, no, and like this. Okay, so this is one cell. Okay, there are intercalated this here. So this is one cell. This one. Okay, that one. So if we go to animated part, no? So this one. The cell is also the shape of the cell is also letter Y. So if you look at this one, this is one cell. Okay, this is one description of the cardiac muscle cell. They are branching, and their individual cell, the shape is Y. Okay, so this intercalated, this is very important. Here we can find the desmosomes and the gap junction in which the cells of the cardiac muscle are intact or connected to each other and cannot be pulled apart because of the desmosomes. And the gap junction, there is a way in which there is exchanges of ions in between the cells of the cardiac muscle or cardiac muscle cell. Okay, so that the conduction system is very accurate and very efficient. So let's look now in the conduction system. So here, the first node is the SA node. Okay, this is the first node, the SA node. And it is called the pacemaker of the heart. Okay, so it is located where? Here. No? It is located on the right atrium. Be specific, in the superior part of the right atrium. Very near to the superior vena cava. So this is the superior vena cava. At the base of the superior vena cava, we can find this SA node. So this is the SA node. Okay? Remember the characteristic of the node, no? It emits impulses without nerve stimulation. So without the brain controlling it, it will emit in a rhythm, no? The rhythm is 60 to 100 or 60. We say 60. Okay, so that's the rhythm of this emission of impulses by the SA node. Okay, so what to remember here as a nursing student or as a nurse is the pacemaker. Okay, in the board exam, they always ask, what is the pacemaker of the heart? The answer is the SA node. Okay, so this is the most talk about here, the SA node. Okay, and next to that is the AV node or atrioventricular node. So the name of the atrioventricular node is taken from the location of this AV node on the junction of the atria and ventricle. So this is now the AV node. Okay, so this is the AV node. Okay, so once the impulses is emitted by this SA node, okay, the impulses will spread all throughout the atrium until the AV node. Okay, so once the impulse is sent to AV node, the atria will contract. So atria will contract. Okay, the atria will contract once these impulses are being transmitted all throughout the atria, from the right also until the left, and going to the AV node. Okay, so this AV node also emits impulses, no, around 40 to 60. Okay, so this AV node is also a pacemaker. Okay, it is also a pacemaker, not only the SA node, but the major pacemaker of the heart is the SA node. But this one is slower. Okay, next pacemaker is the bundle of His, or AB bundle, atrioventricular bundle. Okay, so this structure, this one, until here. Okay, so it is called AB bundle because it is bond, no? This is a bond, and it came from the AB. So this the AB bundle, or another name for this one is bundle of His. This is more popular, no? Bundle of His. Okay, is in the intraventricular septum. So the location of this one is intraventricular septum. So we repeat: SA node, AV node, and bundle of His, or AB bundle. Next pacemaker is what we call the bundle branches. So the bundle branches now are these, no? These two. These are bundle branches. So this AB bundle, or bundle of His, branch out, okay, in the interventricular septum. So the branch in the interventricular septum is called the bundle branches. Okay, it's bundle branches. Okay, so the last one is the Purkinje fibers spread within the ventricle walls. Okay, so if you look at this one, okay, so here, from here it goes to the ventricle, in the walls of ventricles, okay, until also here in the papillary muscle, because it is a part of the ventricle wall, okay, that is connected to your heartstring, or cordia tendine. Okay, and here, so this is what they call Purkinje fibers. So there are only five that we have to memorize in the conduction system. It's very easy: the SA node, AV node, okay, AV bundle, or bundle of His, bundle branches, and Purkinje fiber. So we start here, no? This is the SA node, AV node, AV branches, or bundle of His, okay, and then the bundle branches, no? This is the bundle branches, and the Purkinje fiber. Okay, these are the five important pacemaker of the heart. Okay, since we said that they are pacemaker of the heart, they are emitting impulses. So if the SA node dies, your heart will still pump or contract, because your AB node is still present, which is emitting 40, no, to 60 beats per minute. So if this one will die, your heart rate will slow down. Okay, if you remember, some person are having artificial pacemaker. Okay, so they will just put an artificial pacemaker. That's why they said, oh, his heart has battery. It contains battery, in order to substitute the SA node and emit impulses into a rhythmic way, which is 60. Okay, so that's the normal that it should emit. Okay, and if the AB node and SA node is not working, your heart is still contract, because this AB bundle branches, and Purkinje fiber are still emitting impulses that could create contraction. Okay, that could create contraction, but it's not physiologic anymore. It's pathologic anymore that needs to be corrected. So any loss of these impulses from this part of the conduction system would lead to cardiac arrhythmia. So we will have cardiac arrhythmia. Okay? So for you to memorize the conduction system, you go back to our PowerPoint and try to trace the impulses going to the heart. So this one is the one who makes the atria contracts, no? After the impulses are being sent to the AV node. Okay, and then AV node transmit impulses to AV bundle or bundle of his and bundle branches and then Purkinje fiber. Okay, so it's very easy to memorize. Just remember that the conducting system are pacemaker of our heart so that it would run in a rhythmic pattern. No? It will our heart will beat 60 to 100 beats per minute. Okay, so any loss of this pacemaker would lead to a pathologic problem. Okay, so here contraction is initiated by the SA node. So if the question who initiate the contraction is the SA node. Okay, sequential stimulation occurs at the other autorhythmic cells. So it will transmit there, here, 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 and transfer it to AV node. Okay, force cardiac muscle depolarization in one direction from the atria to ventricle. So remember that the depolarization is from one direction only, from atria to ventricle. If you say depolarization, they also term this one as contraction, but it is not about the muscle that contracts. Okay, so it the meaning is, for example, this is the cell. For example, this is the cell, no? Inside the cell is negative. Outside the cell is positive. That is the normal polarity. This is the normal polarity of the cell, no? Okay, so if this one is stimulated, no? The cell is stimulated, the positive ion goes inside the cell, that makes the inside becomes positive and the outside becomes negative. And that is what we call depolarization. The polarity changes. Okay, so when there is a change in polarity, it depolarizes and cause contraction. That is why it is also called contraction. Okay, so the contraction is also one direction from atria to ventricle. Okay, once SA node starts the heartbeat, impulse spread to the AV node. Then the atria contracts. Okay, so here, sir, you said that the ventricle is the only one contracting. No, the atria also contract. For example, this is the blood inside the atria. No? And before the valve will close, the atria will contract to add additional blood inside the ventricle. So they will add additional blood so that the ventricle will stretch more. Okay? They will stretch more. And the more the muscle is stretched, the more it will contract. Okay? That is a Starling's law of the heart. Starling. Okay? That is Starling's law of the heart. Okay, so the more the muscle is stretched, the more it will contract. Okay, So the AB node, uh, at the AB node, the impulse passes through the AB bundle branches and Purkinje fiber. So what is important here is you know where is the direction. Okay, and the contraction is on one-way direction. It begins with the atria and it goes to the ventricle. Okay, so when the ventricle contracts, the blood is ejected from the ventricles to the aorta and pulmonary trunk as the ventricle contracts. So when the ventricle contracts, you know that this valve will close. Okay, this valve will close and blood will go to the aorta and also to the pulmonary trunk. Here. Okay, and go to the lungs. So let us review again. So this is the SA node. This is AB node. Okay, impulses is initiated by our SA node all throughout the atrium, including the AV node, and then the atria will contract, okay, pushing extra blood to the ventricle, and then this now AV node will pass to AV bundle or bundle wrist to bundle branches, and then to the Purkinje fiber, and then the ventricle will now contract. Okay, that is the conduction system of the heart. Before I forgot, no, so if you are going to monitor the electrical conductivity of the heart, the machine that you are going to use is the ECG, okay? Electrocardiogram, or sometimes they call it EKG, electrocardiogram. So maybe you have experienced this one. They are going to put wires on your chest. Then later on, you can see a strip, paper strip with graph inside. So that is ECG. They are monitoring the electrical conductivity of the heart. Any abnormality with the electrical conductivity of the heart, there will be a problem in cardiac output. Okay, so what is the importance of studying this one? What is the importance of the electrical conduction of the heart in nursing? Okay, so if there is a deviation or problem in the electrical conductivity of the heart, there will be cardiac arrhythmia. Okay, and cardiac arrhythmia is always been taught in nursing. Okay, because this is an abnormality that we should not ignore, and we always encounter this one. No? If the AV node is damaged, so it says here, AV node is damaged, okay, releases them from the control of SA node, there will be heart block, meaning the SA node cannot connect to the AV node. Okay, so will the heart will the heart by contract or not? Yes, it will contract. Okay, it will contract, but in a slow way because it is only the AV node that is working. So it is slower if you have heart block. So result in a slower heart rate as ventricle contract at their own rate. So at their own rate, so 40 to 60 only. So it is dangerous that you have a very slow heartbeat because the cardiac output will be very low. Okay? So this word ischemia, lack of adequate oxygen supply to the heart. Okay? So always remember this word ischemia and fibrillation. Okay, this is one of the most popular problem in the conduction system. This is a rapid, uncoordinated shuddering of the heart muscle. So the beat usually very high, no? Around 400, 250 to 400 beats per minute. So ganun, imagine that your heartbeat is beating like that and it will be very dangerous. Okay, so words that are very important to us is this one, tachycardia. Tachy means rapid or fast. Brady means slow. Okay, so our standard is the 160. So if it is below 60, it's called bradycardia, below 60, no? And if it is below 100, above 100, it's called tachycardia. So this one, memorize this one as a part of your ABC in nursing. No? Tachycardia, bradycardia, tachycardia, bradycardia. Okay, so let us all repeat it again. If we are going to draw our heart, we draw our heart like this. Okay. Example, this is your heart. It has four chambers. So this is the septum. Okay. So this is the right atrium, left atrium. This is the right ventricle, left ventricle. Okay. So the first one is the SA node. Okay. It beats faster than the AV node. So this is the AV node, and this is the AV bundle, and then more bundle of his, and this is the bundle branches, no? And then Purkinje fiber. Uh, we have Purkinje fiber. Okay, bundle branches and Purkinje fiber. Okay, that is the conduction system of the heart. So we summarize, no? The SA node is the pacemaker or the major pacemaker of the heart. The, and then it emits 60 beats per minute. And then the AB node is the second pacemaker of the heart, but it is slower, which is the 40 to 60, no? And then we have the AB bundle or bundle of His, and then bundle branches, and then 4 kg fiber. Okay? So, what is the importance of studying this one?